Good morning, girls. How are you? I hope you are all doing fine. Okay. Today, in our first period, we will be finishing lesson 19.3. I just want to go through the examples I left for you, as well as we are going to be doing some extra examples. Okay, if you remember, lesson 19.3 were named Proving Lines Are Parallel. In lesson 19.2, we took how to prove or what will happen if two lines are parallel and they are cut with a transversal, like in here, for example. And we said that we had something called alternate angle theorem, same side angle postulate, and the corresponding angle theorem, right? All of these came from the word that what happened in the beginning, if L is parallel to M, then these things are going to happen. But in this lesson, proving lines are parallel, we took the converse of the theorems, if you remember. We said that we have three main things: converse of corresponding angle theorem, converse of alternate interior angle theorem, and converse of same side angle postulate. This is what we talked about, right? And we said that in converse, you are swapping, which means instead of saying if L is parallel to M, then the angles are going to be equal. No, you are doing the opposite. If the angles are equal, then the two lines are parallel. And according to this, we had our first example that I left for you, which was number 4 and number 5 in page 957. Okay, explain why the lines are parallel. We want to prove why L1 is parallel to L2. And when he is telling you to explain or to prove, he means he wants you to tell him it's according to which converse of which theorem. And we said how many theorems we have, or how many postulates, or how many converse we have. We have 3. First of all, we have the converse of corresponding angle. We have the corresponding angle theorem. We have the converse of alternate interior angle theorem, and we have the converse of same side interior postulate, right? This is what we said. Okay, actually, before we start solving number 4 and 5, we need to know the main difference between postulate and theorem. Postulate versus theorem. I think we mixed them up before. So actually, a postulate is a statement that is accepted as true without proof, which means it's always true. You don't need to prove it. There will never be a question about proving a postulate. But theorem is an important statement that must be proved before it can be accepted. So a postulate is something true, whatever happens, it's always true. So you don't need to prove it, or you don't need to say why did it happen. It's always true. You don't need to give a reason for this. This is a postulate. But for a theorem is the opposite. Theorem is something true, but you have to tell me why is it true. You have to prove why is it true before we accept it. That's why when we are doing the proof thing, the two column, the paragraph proof, the flow proof, you are always proving a theorem, not a postulate. Take care. Which means the same side interior postulate or its converse will never be proved. But the opposite for the corresponding angle theorem and the alternate interior angle theorem. Since they are theorems, that's why we can do a proof for them. Okay? Okay. So going back to our book. We said we were in page 957 and we need to solve question 4 and question 5. It is supposed that all of the pieces here are just like this tile, which means that this angle is 120, this is 60, this is 120, and this is 60. Again, this is 120, you are repeating the tile, 120, 60, 120, and 60, right? And he is telling you, what about angle 1 and angle 2? What about angle 1 and angle 2? Angle 1 here is 120 because it is the same as this. And angle 2 here, again, it's a 120 because it is the same as this, right? Since both of them are equal, both of them are congruent, we proved that angle 1 and angle 2 are congruent, right? They are congruent. They are in the place of what? Let's consider all the 4 angles that we have. 1 and 2, are they corresponding angle? Do they form an F together? Actually, no. For an F to happen, 1 will be with this angle, not this. So no, this is not a corresponding angle. Are they same side interior angle? Again, no. Same side will be this angle with this. So this is not the same side. Let's continue. Are they alternate exterior? Actually, alternate exterior will be outside the lines. So they are alternate what? They are alternate interior. They are forming a Z. It's a flipped Z, but it's a Z. They are alternate, they are opposite to each other, and they are inside the line, so they are alternate interior. So we proved that 2 angles in the place of alternate interior angles are congruent. So we can say that L1 is parallel to L2 by the converse of alternate interior angle. By the converse of, do not forget to write the converse word. By the converse of alternate interior angles. Theorem. طبعا theorem. Okay, let's think about question 5. In here we prove they are parallel using the converse of alternate interior angle, converse of alternate interior angle theorem, and they were equal. Let's think about 1 and 2 together. First of all, 1 and 2, angle 1 is 60, angle 2 is 120. It's very obvious that they are not equal. Let's check the other thing. Are they supplementary? Actually, yes, they are supplementary. If you add 120 to 60, it will give you a what? It will give you a 180 exactly, right? So 1 and 2 are supplementary. 1 and 2 are the places of which angles? Both of them are together supplementary. So these are same side interior. So since they are supplementary and they are in the place of the same side interior angle, we can prove that L1 is parallel to L2. So we are going to write that L1 is parallel to L2 because angle 1 and angle 2 are supplementary using the converse of same side interior postulate. And I will give you the answers now. It will be written in this way. Let's read. Measure angle 1 equal 120, measure angle 2 equal 120. They are congruent alternate interior angle. So the lines are parallel because of the converse of the alternate interior angle theorem. In here, angle 1 is 120, angle 2 is 60. They are supplementary. The lines are parallel because of the converse of same side interior angle postulate. The only postulate we have. And for the other things, they are theorems. Okay. After we did this, I left for you as well after number 4 and number 5. If you remember, this page was cancelled. And then we jumped to here. And I left for you number 8 and number 9 in page 960. Question 8 and question 9 was a homework. Okay, let's read them. Identify the type of angle pair described in the given condition. What does it mean to identify the type? How many types of angle pair we have? We have 4 types. We have same side interior angles. We have corresponding angles. We have alternate interior angles. We have alternate exterior angles. So he is telling you to identify what type of this angle. And according to this, will the lines be congruent, parallel or not? Okay, let's see. Measure angle 3 plus measure angle 6 is 180. They are supplementary. Let's see, where is 3? Where is 6? These two places together form the pair of same side interior angle, right? So angle 3 and angle 6 are same side interior angles, and they are what? They are supplementary. So L is parallel to M using converse of same side interior angle postulate. And I will show you the answer now. Just understand with me, how are we thinking? What about angle 2? He is telling you here that angle 2 is congruent to angle 6. Let's see, where is angle 2? Yes, where is angle 6? Here. And they are congruent. Are they same side interior angle? No. Are they alternate interior angle? No. But they are corresponding angle because they are in the shape of an F. They are in the shape of the F. So these two angles are corresponding angles. And since they are congruent, so we can say that what? We can say that L is parallel to M using the converse of corresponding angle theorem. And then let's see the answers. In here, yes. First of all, he told you this is a same side interior angle by the converse of the same side interior angle postulate. And then here, those were corresponding angles, so using the converse of the corresponding angle theorem. Okay, okay. Let's check together as well the evaluate section, the problem that was left for you in the evaluate section. Beginning by number 1. Use two of the given statements together to complete statement above the diagram to illustrate the corresponding angle theorem, then write its converse. In number 1 and in number 2, in number 3, 1, 2, and 3, here he is doing what? Here, girls, he is trying to make you practice on how to write a theorem and then how to write its converse. We said, what is the difference between both? You are just going to what? You are just going to swap them. Swap the two sentences. Swap the two events. So let's read. First of all, he is talking about corresponding angle theorem. Let's go back to our figure. For a corresponding angle theorem with angle 1, which is corresponding with angle 1? Angle what? Angle 5, right? So we are going to write by the theorem. If what happens, then the angles are congruent. If line L is parallel to M. So this is what we are going to write here. If L is parallel to M, then angle 1 is congruent to angle 5, right? Let's do it together. It's very important to understand how to write a theorem and its converse. Really, this is very, very important. Okay, let's do it together. So in here, I'm going to write if L is parallel to M, then angle 1 will be congruent to angle what? What should I write in here? Angle 5, right? Okay, by its converse. In here, the two events is L is parallel to M and angle 1 is congruent to angle 5. In the converse, I'm going to write if what? If angle 1 is congruent to angle 5, then L will be parallel to M. So I swapped the two events. Okay, what about the same side interior angle postulate? Let's go in here and see what is in our figure is same side interior angle with angle 3. Let's go back to our figure and see which is with angle 3. With angle 3, it's angle 6. It's angle 6. So we are going to write here if, and I will write L is parallel to M, then angle 6 plus angle 3 will be supplementary. And then here in the converse, I'm going to write if angle 6 plus angle 3 is equal to 180, then L will be parallel to M. And then for the last one, what about the alternate interior angle? What is alternate angle? Alternate interior angle with angle 6. Let's go back to our figure and see. With angle 6, it will be angle 4. It will be angle 4. It is the one doing a Z with angle 6. So I'm going to write here, if again L was parallel to M, then angle 4 will be congruent to angle 6. And then here I'm going to write for him, if angle 4 was congruent to angle 6, then L will be parallel to M. So this is how you can write a theorem and then how to write its converse. We are writing a theorem and then how to write its converse. Okay? Okay. Let's go back to our book. So we did 1 and we did 2 and we did 3. Okay, number 4 was for you to do it as well. I think it was very, very easy. In here, you are trying to tell me if angle 2 is congruent to angle 6. If angle 2 is congruent to angle 6. So it's going to be the converse of corresponding angle theorem or same side or alternate interior. Of course, 2 and 6 will be, they are what? They are corresponding. So I'm going to write A in here. So A is the corresponding angle theorem. What about B? 3 and 5. This is what? This is alternate interior. So B will be in here. What about C? 4 and 5 are supplementary. 4 and 5 are supplementary. Okay, 4 and 5 are what? Are they corresponding? No. Are they alternate interior? No. They are what? They are same side interior. So number C is going to be here. But till now, A, B, and C. Let's check D. D is 4 and 8. 4 and 8 are what? Again, they are corresponding. So I'm going to write D in here. So A and D. What about measure angle 3 plus measure angle 6 equal 180? These two angles together are same side. So number E is going to be in here. And then for number F, 4 and 6 are congruent. Those two angles are alternate interior. So number F is going to be in here. Okay. Okay. For now, I'm going to do number 6 as a classwork. Number 6 in page, we are now in page 962. 962. Okay. Let's check how to solve question 6. We have this diagram in here, and of course, L is parallel to M. Or we want to prove that L is parallel to M, and we have these angles in here 1, 2, 3, 4, 5, 6, and so on. In number 6, the question is what must be true about angle 6 and angle 3 for the lines to be parallel, and name the postulate or theorem. Angle 6 and number 3. They should be what so that the lines will be parallel? They should be equal? No. But they should be what? They should be supplementary because these two angles are same side interior angles, right? Because they are in the place of same side interior angles. So for question 6, I'm going to tell him that we used the converse of which theorem? We are using the converse of the same side interior angle. So in here, let's write in here, I'm going to tell him angle 6 and angle 3 are supplementary, should be supplementary. If they are supplementary, so using the converse of same side interior what? Theorem or postulate? Postulate. If they were supplementary, using the converse of the same side interior postulate, I can say that these two lines are going to be what? Are going to be parallel. Okay. Number 7 was left for you to do it. Let's check it. Suppose that measure angle 4 is 3x plus 5 and measure angle 5 is x plus 95, where x is equal to 20. Are the lines parallel or no? First of all, he gave you measure angle 4 equal to whatever in x and angle 5 equal to whatever in x, and he is giving you the value of x. So the first thing I have to think about is doing what? Substituting, right? I have to substitute this x in here and in there, and then I will see what's happening. I will take it from here, I mean. Let's do it. Let's beginning by angle 4. Angle 4 will be 3 multiply 20 plus 5, right? 3 multiply 20 is a 60 plus 5. It's going to be a 65. Okay, very good. Let's check what about angle 5. For angle 5, it's going to be 20 plus 95. 20 plus 95 is, I think it's going to be 115. 115. Let's check it together. 20 plus 95, exactly, yes, 150. It's very obvious that these two angles together are not equal. But are they supplementary? Let's check. Angle 4 plus angle 5 is going to be 65 plus 115, which is going to be exactly 180. So they are supplementary or not? They are supplementary. And if you go back to the figure, and check what about 4 and 5, sorry, you will actually see that 4 is here. 4 and 5 are what? They are same side interior angles. They are same side interior angles. So I'm going to tell him again, using the converse of what? Using the converse of same side interior postulate. Again, we use the same thing as in number 6. It is the same as in number 6. Okay. What else was left for you? I don't think that question 8 was left for you. Just let me check. No, you were supposed to do number 7, number 9. Yes, number 9 and number 10. Yes, let's do number 9 and number 10. Let's do 9 and 10. Okay. In here, use a converse to answer each question. What value of x makes the horizontal parts of the letter Z parallel? What is this? What is the horizontal parts of letter Z? Horizontal means what? I don't think you forgot, right? Horizontal means a line which is like x-axis. Vertical mean a line which is like y-axis. So where is the horizontal parts of Z? How many parts of Z we have? We have 3 parts. We have this, and then we have this, and then we have this. Which of them is horizontal? We have this is horizontal, and this is horizontal. So what will happen so that these 2 lines are going to be parallel? Imagine, girls, that these actually is just like having this. As if we just have two lines like in here. If the Z is confusing you, as if we have 2 lines like this, and then we have angle here equal to x plus 25, and the angle here equal to 2x. So what should happen to these 2 angles so that the 2 lines are going to be parallel? These 2 angles together, girls, which are these 2? They form the what? Are they same side interior? No. Are they corresponding? No. Are they alternate exterior? Again, no. It's very obvious. They are alternate to each other, and they are inside, and actually they are forming the letter Z. So it's very obvious that they are what? They are alternate interior. So for them to be alternate interior angles, and to make these two lines together parallel. These two angles should be what? Should be congruent, yes. So this is what we are going to write. We are going to write that for this to happen, x plus 25 should be equal to what? Should be equal to 2x, right? Very good. And then what should I do? I should solve this. How can I solve this? Put x's together and the numbers together. So let's flip. I'm going to flip x in here, 2x in here, and 20. Or actually, there is an easier way. Why don't we flip x only right away in here? Yani x will be flipped to the other side. So I'm going to write that 25 as it is will be equal to 2x minus x right away, which means that 25 will be equal to x. So x is going to be equal to 25. So if x is equal to 25, these two angles are going to be equal, because actually 25 plus 25 is 50, and 2 multiply 25 is 50. So this is going to be 50, and this is 50. So these two angles are going to be congruent. So using the converse of what? The converse of alternate interior angle theorem. Okay, let's check question 10. What about question 10? What value of x makes the vertical parts of letter n parallel? Where are the vertical parts of letter n? We have in letter n this part and this part and this part. The vertical parts are only this and this. This is nothing. This is inclined. So this and this. So how can I make these two lines parallel if these two angles are what? Again, ask yourself, these two angles together, they form a what? You have to flip your head, girls. Try to flip your head to see the Z. Try to flip it to the right. Try to do it. Try to flip your head to the right. You will see that actually the N letter is actually a Z. Here it is. It's a Z. It's coming from here, going up, going down. This is a letter Z. So these two angles together form a Z. So they should be what? Again, they should be equal using the alternate interior angle theorem again, right? So again, I'm going to write for him here that 5x should be equal to what? 2x plus 9. And then solving, I'm going to flip 2x to the other side. So 5x minus 2x is going to be a 9. And then 5x minus 2x is 3x equal to a 9. And then I will divide both sides by 3 to get rid of the 3. So x is going to be 9 divided by 3 is 3. So x is equal to a 3. So x is equal to 3. Okay? Very well. Let's go to the second part. Let's go to the second question. Okay, we still have 3 questions in this lesson. In page 963, number 11. I left number 11 for you. Let's read it. An overpass intersects 2 lanes of highway. What must the value of x be to ensure that the 2 lanes are parallel? And it's very obvious that the 2 lanes are this and this. Again, ask yourself, for these 2 lines to be parallel, these 2 angles together, it's very obvious. This is 4x, and the one in here in the corner, it's a 2x plus 12. These 2 angles together, ask yourself, they form which pair of angles that we have? Is it corresponding? No. You may be confused. You can tell me, teacher, there is an F in here, so this can be a corresponding. No, no. A corresponding will be 4x with this angle, not this one in the corner. It will be this one in here, so that they will be equal. But actually, no, these together are not corresponding. Are they alternate interior? No, because they are not alternate to each other. They are on the same side. Are they alternate exterior? Actually, no, because they are not outside. They are interior. So I am left with same side because they are on the left, they are on the right side, and they are interior. So same side interior angle. What should happen for the same side interior angle so that the 2 lines are going to be parallel? The 2 angles should be what? Equal? No, they should be what? Supplementary. And supplementary means if I add them together, they will add to a 180 degree, right? So this is what you are going to do in here. Let me show you the answer. 2x plus 12 Yes, he did it right away. So let's do it. It's better for us to do it just to make sure that you understand how to do it. How did we do it? Again, let's do it together. Okay. In here, let's put the two equations together. I'm saying that these two angles should be what? These two angles should be supplementary, right? I mean that 4x plus 2x plus 12 should be 180, right? And then I have a 4x and the 2x together. What should I do with them? I should add them because they are similar. 4x plus 2x is a 6x. So 6x plus 12 equal to 180. And then what should I do with the 12? Shift it to the other side. So 6x is going to be equal to 180 minus 12. Let's check right away. What is 180 minus 12? 180 minus 12 is 168. 168. And then what should I do with the 6? Divide by 6. Divide by 6, right? So we will find x right away. After dividing by 6, let's divide by 6. The answer will be 28. So x is equal to 28. Right? So if x is equal to 28, these two angles together are going to be supplementary so that the two lines are going to be parallel. Understood? Okay. We still have two questions which are, unfortunately, they are the one of the proof. Okay, please concentrate with me. Number 15 and number 16. Remember when I gave you the difference between a postulate and a theorem? You remember? We said that a theorem is something need to be proved. Yani it's a statement which is correct, but you have to prove it. A postulate is something always true. You don't need to prove it. It's always true. Whenever it happens, it's always true. You don't need to tell me why did it happen, how did it happen. No, it's always true. In question 15, write a two-column proof, statements and reason, of the converse of the alternate interior angle theorem. What does he mean? He means that if given that line L and M are cut by transversal, so that angle 1 and angle 2 are parallel, are equal, sorry. Angle is, he is telling you, if angle 1 is congruent to angle 2, can you tell me why L is parallel to M? You can tell me, teacher, it's according to the converse of the alternate interior angle theorem. Yes, very good. But you said it's a what? It's a theorem. So theorem needs to be proved. You need to tell me why is it true. I know it's according to this theorem, but you have to tell me why is this theorem a true statement. Let's do it together. First of all, we said before, whenever you have a two-column proof, what is the first thing you should write? Your givens. I have how many given? We have here 2 givens. So the first line is going to be line L and M are cut by transversal, given, and the angle 1 is congruent to angle 2, given. Right? And then, before we write anything, let's think, and then we will write. Okay. You remember, again, a postulate is something not needed to be proved, right? And the postulate, the only postulate that we had in this lesson was the same side interior angle postulate, right? And if he tells you that angle 1 and angle 3 are supplementary, which are the same side interior angle, if they are supplementary, so you can write right away that L and M are what? Parallel, because this is a postulate. You don't need to tell me why is it true. It's a postulate, right? So our goal is to try to reach this postulate. Okay, let's think together. Girls, angle 2 and angle 3. Angle 2 and angle 3 together are what? They are a linear pair, right? And this is a postulate as well. It doesn't need anything to prove it. Angle 2 and angle 3 are linear pair. They form a line. Linear pair means what? They are supplementary, right? يعني actually we can write in here that angle 2 plus angle 3 is 180. Angle 2 plus angle 3 is 180, right? Very good. But remember that he told you here that angle 1 is equal to angle 2, right? Using substitution property, instead of angle 2 plus angle 3, it's going to be angle 1 plus angle 3 equal to 180. And since angle 1 plus angle 3 equal to 180, and since we have the converse of the same side interior angle is happening, so we can write that we can prove that L is parallel to M. A little bit confusing, right? Let's read the answer again. Here it is, your answer. What did he write in here? Let's read it. First of all, the givens, as we said, that lines L and M are cut by transversal and that angle 1 is congruent to angle 2. This is a given. And then he told you that angle 1 is equal to angle 2, definition of congruence. You don't need to write this even. Yani angle 1 is congruent to angle 2 is enough. Angle 2 and angle 3 are supplementary. Why? Because they are linear pair, right? So angle 2 plus angle 3 is 180. This is the definition of supplementary, right? By the way, you can write this right away, but instead of number 3, you can jump to number 4 right away. You can tell me measure angle 2 plus measure angle 3 equal 180 because this is a linear pair. And you don't need to write everything in details. Just write with your own understanding. Okay, angle 2 plus angle 3 equal to 180. And from number 2, didn't we say that angle 1 is equal to angle 2? Well, we can remove angle 1 from here and put angle 2 instead. The opposite, sorry. Here it was 2 plus 3, right? So we can remove 2 from here and put 1 instead. So this is what we did. The measure angle 1 plus measure angle 3 is 180, using the substitution property of equality. Since angle 1 and plus angle 3 is 180, so we can say that they are what? They are supplementary. Definition of supplementary. Since they are supplementary, using the converse of same side interior postulate that doesn't need any proof, we can write that L is parallel to M. So always to prove a theorem, girls, you have to reach a postulate. To prove a theorem, you have to reach a postulate. Because after you reach a postulate is always true. You don't need to prove it. Whenever you reach it, so this it's always true. Okay? Okay. Let's go to number 16, the last thing in this lesson, before we start our new lesson. Write a two-column proof of the converse of the corresponding angle theorem, given that line L and M are cut by transversal, and this time angle 1 is congruent to angle 2. Again, you can tell me, teacher, since angle 1 is equal to angle 2 and they are corresponding using the converse, so they are parallel right away. But remember, the converse of the corresponding angle, what? Theorem. And theorem needs what? Needs a postulate to prove it. And the only postulate that we took was the same side interior. So I need to reach that angle 3 plus angle 2 are supplementary. How to reach it? Again, let's think before we write. Didn't we say that 1 is equal to 2? Yes. 1 and 3 together are what? Are linear pair. Again, the same idea. 1 and 3 are linear pair. So 1 plus 3 is 180, right? We can remove 1 and put what instead? 2. So 2 plus 3 is 180. Using the converse of the same side interior postulate, then L is parallel to what? Parallel to M. Let's read the answer. First of all, the given, and then the definition of congruence, the line that actually doesn't have any a lot of importance. And then 1 and 3 are supplementary because they are linear pair. It means that the addition is 180, which is the definition of supplementary. And since angle 1 is equal to angle 2, we can remove 1 from here and put 2 instead using the substitution property of equality. Since they are supplementary, so using the converse of the same side interior angle postulate, so L is going to be parallel to M. Right? Okay. Very, very good. This lesson is done. we are going to start in this video in a very, very small part of the new lesson, and then we will complete, inshallah, by 11 o'clock in the second period. Okay, girls. Lesson 19.4 is called perpendicular lines. Perpendicular lines. What is a perpendicular line? Perpendicular lines means when two lines intersect together and they form an angle of what? 90 degrees. Perpendicular lines is when you have two lines intersecting together, just like in here, for example, like in here, we have two lines intersecting together, and when they are intersecting, they form an angle of 90 degrees. This is called perpendicular lines. Okay, the first thing that we are going to do is something very, very geometrical, something very, very architectural. So I need you to prepare, please, a ruler and a compass. You know what is the compass, right? The compass. Okay, what are you going to be required to do? You are required to graph or construct a perpendicular bisector of AB using a ruler and a compass. First of all, what is a perpendicular bisector of AB? Let's understand it before we graph it. AB is a line segment. Can you see this line segment up here, AB? This is my line segment, AB. What's required from you is to graph a perpendicular line. I want you to understand it very, very well with me. So let's say that I have a line in here. This is AB, for example. To graph a perpendicular, this can be a perpendicular, and the angle here is 90. This can be a perpendicular, and the angle here will be 90. But the name of the lesson or the thing that you want is called a perpendicular bisector. So it's not just a perpendicular, it's bisector as well. What does a perpendicular bisector mean? Perpendicular bisector means if this is A and this is B, and let's consider, for example, that AB was, for example, 6 centimeters. Perpendicular bisector means that when you draw a line, it's not just going to be forming a 90 degree in here, it's bisecting the line into two equal parts as well. This is called a perpendicular because this is 90 degree, bisector because it is bisecting the line segment into two equal parts. So again, a perpendicular bisector is not just any two perpendicular lines together. No, perpendicular bisector means that I have a line which is perpendicular to a segment and it is bisecting it into two equal parts. So this is called perpendicular bisector. How to graph it? I'm going to show you using a certain application online. It will teach you exactly what to do. It will teach you exactly what to do exactly, because you are going to be required to do it in the homework. Okay, so please just understand with me very, very well. Okay, how to construct a perpendicular bisector of a line segment using a compass and a ruler. First of all, the line will be drawn for you. The line will be drawn for you. Yeah, just wait, just wait. He did everything. What's happening? So again, the line is going to be given for you and you are required to graph a perpendicular bisector. You know what is the problem? The problem is that you will not be, don't tell me, teacher, I'm just going to get a ruler and draw a line. So are you sure that this line is exactly 90 degrees? Are you sure that this line is exactly bisecting? No. So it's better to use the compass and the ruler. How to use the compass and the ruler? The first step is you are going to get your compass. Your compass always have two sides. The side with the pin and the sides with the pen or the pencil. The side with the pin, the thing that's going to be like be pinned inside the paper, and the pencil that you are going to draw with. So the first thing you are going to do is to put your pen on the first point of the line segment. And then you are going to slowly open your compass. You are going to open your compass to a certain, just open it so that it will be bigger than half of the line segment. Yeah, open it big, open it wide. Okay, but the first thing, I will put the pen in here, and then I will open my compass wide, and then I'm going to go draw an arc up, draw an arc down. Did you see what happened? Did you see what happened? Again, my line segment wasn't here. And then I got my compass. I opened my compass. And then I draw an arc up, and then I draw an arc down. Okay? And then, without adjusting your compass, please do not close your compass or widen it up. With the same width, you are just going to put the point. Instead of here, put it here. Yes, exactly. And then draw an arc and draw an arc. Again, did you see what happened? What happened again? Let's check it. I just went and put the point in here with the same width. Draw a line, draw a line. And then you have these two intersection points. Can't you see it? An intersection point up and an intersection point down. What should I do with them? The ruler is now in handy. Get your ruler and draw a line from here to there. And this is your perpendicular bisector. It's exactly 90 degrees, and the two lines or the two sides are exactly what? Exactly equal. Okay? Okay? Very easy, right? Very easy. So going back to our book, what are you going to do? Actually, all of the things here are already drawn for you. You are just going to learn this because in the homework, in the first question, you are going to be required to do it. Okay? Okay, girls. So by this, we finished the first page in the new lesson, page 965. And in the second period, inshallah, we are going to be starting in Explain 1 in page 966. Thank you very much and see you next period.